Hello everyone, welcome back to my channel. Today let's go over a medium question that I just solved on my own, so I'm really happy about this. I basically got the intuition pretty quickly and was able to come up with my own solution to this without any help, so again I'm really proud of that. So let me show you how I did it. So this one's called maximize distance to the closest person. Basically you're given a binary array of ones and zeros, and basically you want to find the distance where, okay, so for this 0, for example, the farthest away a 1 is the maximum. That's 2. If you put it here, that's 1. That's smaller than 2. Here, although that's 3, that the right-hand side still has its 1, so you have to go with the smaller one. So think greedy a little bit, and hope you get the idea. So here, it's just going to be 3 because, again, there's no 1 to the right. So the idea is to use a binary search. So basically, let's first of all keep track of where every single one appears, because the indices are going to be sorted order because we're going from left to right, iterating, scanning through the array. So let's call this ones for I, S, and enumerate seats. If S is equal to 1, then ones.append I. So that's going to be valid. And so now if we print ones, you get all the indexes of the ones. So 0, 4, 6. So cool. So now what we want to do is actually also keep track of the zeros. So otherwise zeros.append I, because we want to keep track of the person, whoever Alex is going to sit, has to be at a location that's 0 that's already not taken up, right? So what we're going to do is iterate over zeros, and let's print 0 and 1s, and I think you'll get the idea. So okay, so now you can see that 1 is supposed to be put it here, right? So the left-hand side distance is 1, the right-hand side distance is 3, right? So here it's 2 and 2, so that's balanced. So what we're going to do is use a binary search. So let's say BL is bisect left inside of 1s and Z, and you might have to play around with this a little bit, but if you print BL, okay, so we get 1, so that's the bigger one, even though it's bisect left. 2, index 1 is the bigger one. Index 3, that's still bigger than this one. Index 2 is 6, is still bigger than the current value, the current Z value of 5. So now what you want to do is say, well, this is supposed to be the right-hand side, actually. And then the left-hand side comes after this. It's supposed to be our BR minus 1 because that's supposed to be 0, right? So now if we print BL, BR, just the order is a little messed up, but that's the idea behind it. So now we can see 0 and 1 is exactly in between where 1 is supposed to go. So cool. So now we got to make sure these are in bounds, right? So we can actually say we have a left and a right side that has a 1 because we're looking at the zeros. We're iterating over the zeros array. So now we can say if BL is less than length of 1s and BR is less than length of 1s, then we have left and right side, we have a 1. So let's say LL is the left side and RR is the right side. So the LL is just going to be 1s of BL and then 1s of BR. And let's call the current one, the mid is just the Z value, right? The index that we may want to sit at. So that's going to be LL, mid, and RR. So cool, 014, 024, and 034, and 456. So now that's perfect. So basically what we want to do is keep track, okay, what if there's not a right side, right? So if BR or if BL is less than length of 1s, then there's just the left side, right? So left is just 1s of BL. That means there's no 1 to the right side. So for example, if we had this, there's no 1 to the right side, so we only care about the closest one on the left side. So then we can just say print LL and mid. Otherwise, if there's no right side, then we care. If there's no right side, if there's no left side, then we just care about the right side. So let's print RR and mid. We actually, yes, okay. So LL is 1 of BL. The mid is just going to be Z. So Z. So we can get rid of this now. Cool. So now we have what we need. And now is where it gets a little tricky, because what we want to do is take the left difference and the right difference and do the absolute value, because the distance, it doesn't matter if you're bigger or less than, the distance is like 2. So it's going to be absolute of LL minus mid, or minus Z, same thing, RR minus mid. Left diff is absolute of LL minus mid, same here. R diff is RR minus mid. Cool. So now let's print the left diff and the right diff. Let's get rid of these. Equals 2. So LL minus mid, that's just Z. Okay, so now what you're gonna do is keep track of the biggest one, right? So, except we have a problem, because let's say you try to sit here, okay, that's 3, but the left-hand side is less than. So if L diff is less than right diff, that means we can only keep track of the left diff, because the right diff isn't valid, because the left diff has a smaller, it's basically the one that kills the whole constraint. So if this is less than this, then we want to maximize our answer, right? It says right here the maximum distance. Then what we can do is say answer is max of answer and left diff. So otherwise, if left diff is bigger than right diff, so okay, let's think about this. Then answer, so right diff is the smaller one. We have to use that. That's the limitation, right? And otherwise here, there's just answer and left diff. Since there's no 2 options, there's only a right or a left. Right diff, and then we can just return answer at the end, right? So after we checked all the zeros, right? Okay, let's see. Right diff is this minus Z. So answer and left diff. So if this is less than this, then we can only use the left diff. If left diff is bigger than right diff, okay, let's see what's going on. Let's print L diff. Supposed to be 1. Oh yeah, okay. So if L diff is equal to right diff, then answer is max of answer and left diff. That's where it's like 2 and 2, right? 0 and 4 are both 2 distance away. So that's the best case scenario. So, and output limit exceeded, cool. So that basically means we just solved it. So again, I was really glad I was able to do this without any help by myself. So it's pretty rare. So let's submit this, and there you go, passes all test cases. Again, this is not the most efficient solution, but I did grind through this by myself, so really happy about that. So that's it for this video. Thank you for watching, and stay tuned for more.